This video is on topic 2.6, resonance and formal charge. And today I'm going to talk to you about the concept of resonance and why it's important for Lewis diagrams. My name is Alice Pudi, and I'm happy to be back with you on AP Daily. In the last topic, I had you draw Lewis diagrams for molecules and ions. So what I'd like you to do is to start this one by drawing the Lewis diagram for carbonate, which is CO3 minus 2. Press pause, answer the question, and then press play when you're ready to begin. In carbonate, the structure should have one double bond between an oxygen and carbon. And the reason that it needs a double bond is otherwise carbon is going to be 2 electrons short of an octet. And because this is an ion, you do need to have the bracket and the 2 minus charge in the corner. So where did you place your double bond? I placed my double bond here, but you could have placed it between the carbon and oxygen on the bottom, or you could have placed it between the carbon and oxygen that's on the right. Any of these places would have been correct, and all of the structures would have been identical and valid. Based on what we know of bonds and lengths, what do we know about the bonds in the carbonate ion? The single bonds should have the same length and the double bond should be shorter, which means that the model predicts that the single bonds and double bonds are different lengths within the carbonate ion. However, if we look at experimental evidence, it does not support this. The experimental evidence shows that all 3 bonds are the exact same length and that they are somewhere between a single bond and a double bond. So what do we do when experimental evidence and our model do not agree? This means that we need to adjust the model. And so what you will do is, in the case of a structure like this, you would draw all 3 structures, and we call these resonance structures. They need to be joined by double arrows, and the double arrows represent the fact that the real molecule is actually an average of all 3 of these different structures that are here. Another way to represent this instead of the 3 structures is that you could draw a hybrid structure, where in the hybrid structure, the double bond, so this pair of electrons that's in the double bond, is actually shared between all 3 bonds instead of just between 2 atoms. In this case, because of this, each of these bonds would be a 1 1/3 bond, and we would represent the 3rd bond then with dotted line as opposed to a solid line. Let's take a look at an example. So for the ion HCO3 2 1 minus, which is the formate ion, please draw all the possible resonance structures. And again, press pause, answer the question, and press play when you're ready to continue. In the case of formate, again, you are going to need a double bond between the carbon and one of the oxygens. And because both oxygens are identical, it could have been with the oxygen that's on the right, or it could have been with the oxygen that's on the bottom. Again, because this is an ion, you do need to have the square bracket and the 1 minus charge. And because these are all identical, so the carbon oxygen bonds are identical, that means that they'll have a bond order of 1.5. Nitric acid, which is HNO3, is a strong acid. The Lewis diagram of nitric acid is given here, and there are 3 bonds that are labeled X, Y, and Z. So the question is, which of these statements is correct regarding these bonds? And the hint is to think about the possible resonance structures of nitric acid. So please press pause, answer the question, and press play when you're ready to continue. Hopefully you said that the correct statement was C, where X and Y are equal to each other. However, bond Z is at greater than both of those. If we take a look at the resonance structure here, you can see that the double bond, again, could be between the nitrogen and oxygen for bond X or bond Y. And so as a result, That's going to make this a 1.5 bond. However, bond Z cannot be a 1.5 bond, again, because this oxygen is bonded to the hydrogen. So this is only going to be a single bond. So the single bond will be longer than either of bonds X and Y, which are a 1.5 bond. This is the end of the video. Please join me for the